So, hello. Kami nga po pala yung Group 4 at ang didiscuss namin is about woods. So, bago ang lahat, ano nga ba yung mga objectives? After presenting this report, the students are expecting to have a basic knowledge about definition and history, as, as well as usage of the wood, understand the structure and the chemical composition of the wood and the moisture content present in it, wood production and defects on lumber, became aware of its physical and mechanical properties and the testing materials used in order to determine its compliance with the standard given as a construction material, and learned the methods used in wood preservation. So, pagkatapos ng objectives, i-discuss naman natin kung ano ang pagkakasunod-sunod ng topics namin. So, una is yung wood production, introduction na i-discuss ko. Pagkatapos ko ay i-discuss naman ni Eunice yung wood structure. Pagkatapos niya ay types of wood naman na i-discuss ni Kane Belaro at saka yung wood production. Tapos, pagkatapos ng wood production, yung defects in lumber naman na i-discuss ni Jaisel Ronario. Tapos, pagkatapos nun, yung physical and mechanical properties naman ng woods ang i-discuss naman ni Orleans. Tapos nun, yung testing to determine mechanical properties naman ang i-discuss ni Salasbar. Next, yung wood testing materials and equipment naman ang i-discuss ni Polvo. At lastly, ang pinakauling topic namin is yung wood preservation. So, ako nga po pala si Mark Justin at i-discuss ko yung wood introduction. So, una, definition muna tayo. Wood. Wood is an organic material produced by a large number of woody plants and quite variable in properties. If used in building elements, it can play structural, functional, and aesthetic roles at the same time. So, alam naman natin na yung wood ay isang organic material na mula sa mga puno. Dahil nga sa magagandang qualities nito at properties, ito ang isa sa mga bagay na ginamit ng mga tao para magkaroon ng progress sa development sa paglipas ng panahon. Then, ngayon, sa pag ginagamit siya sa building material, ang wood ay kayang-kaya niyang gampanan yung structural, functional, at saka aesthetic roles. Next is yung lumber. Lumber, also known as timber, is a wood that has been processed into beams, planks, a stage in process of wood production. So yung timber or yung lumber is tinatawag siya sa mga wood na na-process na. Pero alam nyo ba, yung lumber at timber, so ayon sa nabasa ko ay may pagkakaiba sila. Sabi daw doon, ang lumber at timber pinagdedebatihan na may differentiation. Tapos sabi doon, isa sa mga pinagdedebatihan na differentiation nila is sa paggamit ng rule of thumb. Sabi doon, lahat ng wood na merong dimension na hindi lalagpas sa 5-inch width pati 5-inch length ay tinatawag na lumber. At lahat naman ng mga wood na na-process na mas mataas ang dimension kaysa dun sa nabanggit kong mga dimension ng lumber is tinatawag na timber. So, dumako naman tayo sa history of wood. So, since ancient time pa nga lang, ginagamit na natin ang wood. Tulad sa Stone Age, around 10,000 years ago, na-invento o nagawa yung first timber home. Tapos, around 9,000 to 5,000 BC, nagawa yung Neolithic Longhouse. Ano ba yung Neolithic Longhouse? Ito yung parang isang long, narrow timber structure na kayang mag-occupy ng 20 to 30 persons. Tapos, dito naman sa Bronze Age naman tayo. 2560 BC, Yung Egyptian ay kinalbo yung mga forest at pinagkukuha yung mga woods para gamiting lever at sledges para sa kanilang pag-build ng Pyramid of Giza. Dito din sa Bronze Age na 'to is na-imbento yung metal saw. Dahil dito nagkaroon ng advancement sa woodworks. Ito yung itsura ng Neolithic Longhouse. Tapos ito naman itsura ng Pyramid of Giza. Tapos dito naman sa Iron Age, dito unang inintroduce yung timber crane. Ano nga ba yung timber crane? Ito yung ginamit ng mga Roman ng mga tao ng Roman Empire para buhatin yung mga mabibigat na materials papunta sa mga matataas na lugar. Dahil dito, nag-improve yung pagbibuild ng structures ng mga Roman Empire. Tapos, sa Middle Age naman, around 50 AD, dito na-introduce yung timber framing. Ano yung timber framing? Ito yung parang structural framing na gamit ay timber. Tapos, Nantian Temple naman, around 882 AD. Ito naman yung pinakamatandang building o wooden building sa China. Tapos, 14th to 17th century, dito naimbento yung water mills. Tapos, pinaka-ginamit na material sa mga water mills is yung wood. Ito yung itsura ng water mill. Tapos, ito naman yung itsura ng Nantian Temple. Tapos, ngayon, sa 21st century, kung babasahin natin sa Pilipinas, hindi na masyadong ginagamit sa mga construction ang woods dahil merong pinagbabawal na ang paggamit ng tropical timber dito sa Pilipinas. Tapos, pero sa ibang bansa, gamit na gamit pa rin siya at ang pinaka-popular na paggamit ng wood sa construction is yung rustic log cabin. At speaking of rustic log cabin, ang granite loma is siya ang pinakamahal at ang pinakamalaking log home sa buong mundo. Ito yung itsura ng granite loma. Next naman natin is wood structure na i-discuss ni Eunice sa balsa. Yun lang po. Salamat.
So, good morning. Yung topic ko for today is topic 2, which is structure of food. Under nito is yung chemical composition of food, pati na rin yung moisture content ng wood. First, sa chemical composition of food, pero tayo cellulose. Yung cellulose yung umuokupa sa kalahati ng wood substance in terms of weight. Yung percentage siya to, hindi siya fixed and nakadepende siya sa type of food sample na gagamitin. It is a long linear molecule with over 7,000 glucoses linked end to end. And habang lumalaki yung puno, yung linear molecules na yun, nag-a-arrange siya into highly ordered strands called fibrils. Next naman is lignin. Yung percentage niya is nakadepende kung softwood or hardwood yung type of wood. Sa softwood, it's 23 to 33% yung na-account niya in terms of weight, while sa hardwood naman is about 16 to 25%. It is a three-dimensional molecule formed by linking 15 to 18 phenolic units called phenylpropanes. Magkasama sila ng hemicellulose na i-report ko rin mamaya na tumutulong para pagdikitin yung tubular cells na meron sa wood. Next naman is hemicellulose. It is a polymeric unit made from sugar molecules. Ang kaibahan nga niya sa cellulose that merong presence ng sugar sa cellular structure ng hemicellulose. Has 50 to 20% of hemicellulose pagdating sa softwood and pagdating naman sa hardwood, meron siyang 20 to 30%. Gaya nga nabanggit ko kanina, silang dalawa ng lignin yung nag-act as natural binding ingredients sa plant materials. Next naman is extractives. It composed of 5 to 30% of food substance. It included dito yung tannins, other polyphenolics, coloring matters, essential oils, fats, resins, waxes, gums, starches, and simple metabolic intermediates kung saan pwede sila matanggal by means of water, acetone, and alcohol. Responsible naman yung extractives sa durability ng wood para malabanan niya yung pagkalat ng fungi decay and insect injuries. Last naman sa chemical composition of wood is yung ash-forming materials. So, it accounts 0.1 to 0.3% of wood material. So, it includes calcium, potassium, phosphate, and silica. So, itong tatlong to, yung chemical structure ng cellulose, lignin, and hemicellulose. Next is moisture content. So, moisture is defined as a liquid such as water in the form of very small drops na either makita natin siya sa substance sa surface or kaya pwede rin naman siya nasa air. So, yung moisture content of food specimen is the weight of water in the specimen expressed as a percentage of the oven dry weight of the wood. So, ano nga ba yung kinalaman ng oven dry method sa pag-calculate ng moisture content ng wood sample? So, yung oven dry method, ito yung method kung saan na-expose natin yung wood sample into certain conditions, especially sa temperature, na-expose natin siya to high temperature hanggang sa mawala yung presence ng water sa loob ng wood sample. So, it is usually dried in an oven at 100 to 105 degrees Celsius or hanggang sa ma-attain na ng wood yung constant weight na kailangan natin. So, yung moisture content ng wood is nakahati sa dalawa. So, first is bound water and yung isa naman ay free water. Yung bound water, ito yung kadalasan makikita sa cell wall ng wood. Sa free water naman, ito yung matatagpuan natin sa cell cavities. Kapag in-expose natin nag-undergo yung wood sample sa oven dry method, kadalasan nawawala dun is free water. Kapag naman yung bound water na lang yung natira sa wood, doon na papasok yung FSP or fiber saturation point. It is the level of saturation at which the cell walls are completely saturated but no free water exists in the cell cavities. So, nagre-range siya from 21 to 32%. Sabi dito, if the moisture content of a wood sample is above the fiber saturation point, considered siya as dimensionally stable. Meanwhile, kapag mas mababa siya dun sa FSP, fixed FSP ng wood, so magkakaroon siya ng dimensional changes. So, ano ba yung sa dimensional changes? So, kapag na-expose siya sa init or tubig, nagkakaroon siya ng either swelling o kaya naman shrinkage. So, ito nga yun. Moisture content results to shrinkage or loss of moisture from the cell walls and swelling naman kapag nagkaroon ng gain of moisture in the cell walls. So, balik tayo dito sa FSP. Yung FSP, pagdating sa computations, although hindi siya kasama talaga sa report, yung ina-assume na value lagi na moisture content, considering yung FSP is 30%. So, ito lang yung report for the structure of food. And next report is about types of food and wood production.
Good day everyone, I'm Jane Emerald Velaro at ang i-report ko po ay yung types of food and wood production. So, sa types of food po muna tayo. So first, there are two classifications of wood, and these are the natural wood and engineered wood. Under the natural wood are the hard and soft woods. So isa-isahin po natin. Natural wood means trees, including yung logs, yung boles or slabs, trunks, branches, and etc. And yung two types of natural wood are hardwood and softwood. So, hardwood is a wood from dicot angiosperm trees. Ang alam niyo naman po yata, angiosperm, ibig sabihin flowering plant, na divided into two groups, monocots and dicots. So, monocot have one seed leaf termed cotyledon, and in fact, monocot short term for monocotyledon. And yung hardwood po is under dicot angiosperm. Dicot obviously having two cotyledons. In temperate and boreal latitudes, they are mostly deciduous or naglalagas po yung leaves nila annually. But in tropics and subtropic, mostly evergreen. Evergreen, ibig sabihin green siya throughout the year at hindi naglalagas yung leaves. So, hardwoods are not necessarily harder than softwoods. So, self-explanatory naman po, pero yun sabihin ko na rin na hindi literally mas matigas ang hardwood kaysa softwood. For example, balsa po, balsa tree is one of the softest and lightest of all woods, pero classified siya as hardwoods. The next type of natural wood is softwood. It is a wood from gymnosperm trees such as conifers. It is the source of about 80% of the world's production of timber, and softwoods are not necessarily softer than hardwood. So, basta ang main difference po nila is hardwood ay nagpo-produce ng leaves while softwoods ay nagpo-produce ng needles. And hardwoods trees are typically slower growers and are considered angiosperm. These deciduous trees, ibig sabihin they shed their leaves annually na nagli-lead sa denser wood. And contrary to their name, softwood are not weaker than hardwoods. In fact, mas mabilis nga silang mag-grow and dahil doon, they are less dense compared sa hardwood. And softwood comes from coniferous trees, ibig sabihin trees that keep their needles all year long. Para mas makita yung differences ng dalawa, let's proceed sa next slides. So the following are the hardwood characteristics. Hardwood have more complex structure than softwoods, dark in color, expensive, slower growth rate, higher density, heavy in weight, more fire resistant than softwood, and strong in compression and tension. So, syempre naglagay din po ako ng examples. First example, East Oak Tree, which is light in color, heavy, ring porous, open grain, hard to work with, and when treated, it looks classy and elegant. Next example is Mahogany, which easy to work with, reddish-brown in color, expensive, strong, and an excellent carving wood and finishes well. Itong next example naman is yung top hardwood tree sources sa Philippines. These are Molave, Camagong, Nara, Yakal, and Tanggili trees. These trees, especially Tanggili, wood can be made into exterior application like for example, window frames, walls, floors, doors, and other durable pieces of furniture. And proceed naman po sa softwood characteristic. Cheaper compared to hardwoods, faster rate of growth, lower density, light in color, light in weight, poor fire resistant, strength in tension but weak in shear. For examples, first is pine tree, which is soft, white or pale in color, lightweight, straight grains and swelling, nutty. Next example, cedar tree. Nutty softwood, red-brown color with light streaks, aromatic and motor repellent, popular wood for lining drawers, chests, and boxes, and brittle wood. And to see for more examples of hardwood and softwoods in the Philippines, yan po, visit the link po sa PPT, provided sa PPT. And po, nag-list na lang po ako ng hardwood and softwood. Sa Philippines po iyan. Kilala po yung mga puno. Next classification of wood is engineered woods, or also called composite wood, man-made wood, or manufactured wood. From its term po, it is a sort of wood that is being manufactured and is treated with chemicals or heat. It includes a range of derivative wood products which are manufactured by binding or fixing the strands, particles, fibers, or veneers or board of wood, together with adhesives or other methods of fixation to form composite materials. Ang primary material used to manufacture engineered woods products is made from same hardwoods and softwoods. Basically, engineered woods is a byproduct of natural woods na dumaan sa manufacturing process. So, engineered wood products are used in variety of applications from home construction to commercial buildings to industrial products. So, ano-ano po yung mga numerous types of engineered woods. First off is plywood, which is a sheet material manufactured from thin layers or piles of wood of veneer. Alteration of the grain is called cross-graining. Cross-graining reduces the tendency of the plywood to split when nailed at the edges. It also reduces expansion and shrinkage, which improves its dimensional stability. And it gives panels consistent strength in all directions. The next type is blackboard. It is a wood-based panel made up of a core of softwood strips glued together. Ang blackboard po ay ideal for doors, panels, shelves, and partitions. Blackboard is made by gluing together a core of softwood strips. And noted dyan that the strips may be up to 28 mm wide and are placed edge to edge between veneers of hardwood. Ang veneers po ay isa pang type yan ng engineered wood, which refers to thin slices of wood that are glued and pressed onto core panels. Then, this sandwich is then glued under high pressure ayon to obtain blackboard. The internal strips are generally made up of lightweight poplar wood or spruce. To achieve maximum strength, it is important to ensure that the core runs lengthways. Blackboard has a very good screw holding and it has good resistance to warping. The next type is veneer, na nagre-refer nga po sa thin slices of wood that are glued and pressed onto core panels. Veneers refers to thin slices of wood, as said, usually thinner than 3 mm or 1/8 inch that typically glued onto core panels. Veneer is obtained either by peeling the trunk of a tree or slicing large rectangular blocks of wood known as flitches. So the appearance of the grain in wood comes from slicing through the growth rings of a tree and depends upon the angle at which the wood is sliced. So nasa cutting technique po nakadepende yung appearance ng product and i-explain ko further yung technique sa wood production. Basta ang idea is nakadepende sa growth rings and sa angle ng pag-cut yung appearance ng wood. The next type is laminates, usually permanently assembled by heat, pressure welding, or adhesives. Lamination is the technique of manufacturing a material in multiple layers. So that yung composite material is ma-achieve ang improved strength, stability, sound insulation, appearance, or other properties from the use of different materials. So laminate is made up of several layers of thin wood that are assembled together with the help of adhesives. So next is particle board, also known as chipboard. Particle board is affordable and environment friendly at pwedeng gamitin for full ceilings, shelves, furniture, and carpentry. It is manufactured by pressing and extruding various wood waste. Yan po nakalagay that from wood chips, sawmill shavings, or even sawdust and a synthetic resin or other suitable binder. Next po is medium density fiberboard or MDF, made by breaking down hardwood or softwood residuals into wood fibers. Yan. Then, i-combine po yon with wax and resin binder para mag-form ng panels by applying high temperature and pressure. MDF po has a smooth finish and consistency. Strong yet easy to work with. Ang advantage nitong paggamit ng MDF is it is generally denser than plywood, pero it can soak up po water faster than plywood, kaya mas malapit siya sa damage kung gagamitin outdoors. Kaya nang sabi ko kanina, Very smooth siya, making it suitable for painting and indoor furniture. So MDF is made up of separated fiber and stronger and much denser than particle board. So lastly, high density fiber board, they're also called hardboard, so or HDF in short. So made out of exploded wood fibers that have been highly compressed. So basically po, explaining how HDF manufactured best describes kung bakit high density fiberboard siya tinawag. Essentially, fine wooden fibers are mixed with resin and then subjected to immense pressure. Yun po. This compression combined with heat results in a composite wood material with high density. Though parehas pong MDF at HDF hindi goods pagdating sa water, pero ang HDF po is more water resistant than MDF. And yung density ng HDF make the MDF stronger. So in addition, it differs from particle board in that the bonding of the wood fibers require no additional materials, although resin is often added. Ayan. So, next topic naman po is wood production. Kung matatandaan nyo dati, ito. Ayan. Nasa picture and ito yung process. So, yan. Yung pitong yan is parang na-discuss ko siya sa last second year, pero i-discuss ko siya ulit. Parang, etong pito is very specific na process siya, manufacturing process ng lumber. May i-discuss po ako na sa next slides na general namang process ng pag-produce ng wood. Dito, very specific siya from pagputol ng puno hanggang sa ma-produce yung lumber sa market. So first, felling, mostly done with gasoline-powered chainsaws. And yung pag-cut ng puno is sa magkabilang side malapit sa base para makontrol yung direction ng paglaglag ng puno. So, tinitrim yung mga sanga and kinakat into convenient legs para yung logs para sa pag-transport. So, ginagamitan ng self-propelled yarder na may telescoping hydraulic tower kapag steep ang terrain. Pagka-transport ng logs, ilalagay yun sa mahabang piles na tinatawag na log decks. At ini-sprayan yun ng tubig para ma-prevent yung pag-dry ng wood at mag-shrink. So next step is debarking and backing. May mga cases na yung outer bark ng logs ay tinatanggal either with sharp tooth grinding wheels or with jet high pressure water. Yun. So, tas yung pagtanggal nung natanggal na bark is pinupulverized and ginagamit pwedeng as fuel sa mills, furnaces, or pwedeng ibenta as decorative garden mulch. So, next step is yung pagkat na. Head rig sawing large logs and band sawing small logs. So, may dalawang production line. Una is para sa large logs muna. Gagamitan ng head rig sawing large logs. Bali yung worker na nasa control ay gumagamit ng computer at laser para tulungan siya i-position at i-reposition yung kada log. Bakit i-reposition? Kasi tuwing ibabalik niya yung log sa saw ng paulit-ulit. Kunwari, bala ganito. After kasi kunwari ma-position yung log gamit laser, then dadaan sa saw para i-cut with a specific size. Tapos, yung may matitira pa na log. Yung matitira na log na yun is babalik mula sa pagka-laser ulit, tas cut hanggang sa kung ilan kayang makat sa isang log. Basta ang sukat ay 4x10 o depende sa sinit na standard size. Tapos, ang average log usually may 7 hanggang 8 piraso na napoproduce na lumber. So, yung isang production line naman ay para sa mga narrower logs na pumupunta sa ibang saw. Yung unang cut ay mula sa magkabilang side, tas ipapadala yung natirang log sa iba pang saw. The sumunod na step is resawing. Yung logs galing sa first production line, nasa first production line ay yung mga logs na may malalaking diameter. Pupunta yun sa pangalawang cut na tinatawag na riso. So, kinakat pa yun sa kalahati. Like kung sinabi ko kanina, kunwari 4x10 yung sinit na sukat, gagawin yun 2x10. So, mamaya babanggitin ko yung mga standard sizes para sa lumber. Tapos yung mga lugs na mula sa second production line, dinadala sa machine na may 8 adjustable circular saws na kayang mag-cut ng lugs into various sizes of woods. Depende na lang yun sa diameter ng lug. So next is drying or seasoning. Yung dalawang production line ay mapupunta sa machine na mag-i-smooth ng edges tas magti-trim off ng kahit anong defects na pwedeng makaapekto sa strength and resistance ng woods. So, imumove yun sa area para i-dry or season. So, kailangan yun to prevent decay and to permit wood to shrink as it dries out. So, pwedeng air-dried or kiln-dried. Depende na yun sa required moisture content na natapos na piraso. So, next is planing, yun, i-smooth lang yung surfaces. Mas prefer na ang planing ay gagawin patapos ng seasoning. I-explain ko sa general wood production kung bakit. Ay, last po pala is yung grading. Explain ko na lang mas detail pa sa next kung ano yung grading. Ayan. Ito po yung sinasabi ko na general wood production. A vast industry has developed to harvest and process wood. Wood is harvested from forest as logs. They are transported to sawmills where they are cut into dimensional shapes to produces a variety of products of engineering applications. So, yun. Kuha sa forest ng wood. Ano po yung mga product na sinabi sa una? Una is yung dimension number. A wood from 2 inches to 5 inches thick, sawn on all 4 sides. Common shapes include 2x4, 2x6, 2x10, 2x12, 4x4, and 4x6. Ayan po yung sabi ko na standard sizes ng lumber. Yan. Yung mga sizes na yon is nagre-refer sa rough sawn lumber. Dimension ng lumber in inches. So, ibig sabihin, yung mga common shapes ay type ng lumber na untreated and cut into planks. And yung mga rough sawn lumber na yun is surfaced to produce smooth surfaces. This removes, kunwari, na-smooth na siya, may matatanggal pa na 1/4 per side. For example, ang actual dimension ng 2x4 are 1.5 inch by 3.5 inch. Bakit? Kasi nabawas ng 0.5 inch sa parehong side. Ang 0.5 inch ay 1/4 ng 2 na galing sa 2x4. So, dimension number is produced in lengths of 8 feet, 24 feet in 2 increments. Next is heavy timber. This is a wood sawn on all 4 sides. Common shapes include 6x6 and 8x8 and larger. So heavy timber includes beams and stringers subjected to bending and post and timbers used as posts and columns. As with the case of dimension lumber, these sizes specify rough sawn dimensions in inches. And so round stock consists of posts and poles used for building poles, marine piling, and utility poles. This is engineered wood and explain ko na siya kanina. And dagdag ko na lang that structural engineered wood products include the following: structural panel, structural wood laminated timber or glue glam, structural composite lumber, and composite structural members. Na example po tayo. Ayan. Yung nasa picture po is an example of structure na ginamitan ng engineered wood. Frames made of structural laminated timber or glue glam. Ito rin po, an arc made of glue glam as well. Ayan. Proceed naman po tayo sa cutting techniques. So, syempre, after makolect yung trees from forest, ito na yung next steps. Sawn wood production includes following: sawing into desired shapes, seasoning, surfacing, grading, and preservative treatment. Preservative treatment po is optional po siya. So, first step, sawing into desired shape. So, the harvested wood is cut into lumber and timber at sawmills using circular saws, bandsaws, or frame saws. The most common patterns for sawing a log are the following. Nasa picture, yung live or plain sawing, quarter sawing, and combination sawing. So, yung difference nila is obvious naman sa pictures kung paano sila i-cut. So, the sawing pattern selected depends on the cross-section of the tree, the capability of the mill and desired product. So plain sewing is a rapid and economic, whereas quarter sewing maximizes the amount of vertical sewn cuts. So, some of the advantages ng different sewing patterns ay summarized din sa table na ito. Ito naman po yung sinasabi ko kanina nakadepende sa appearance ng wood sa growth rings. So, growth rings or annual rings, ayun po yung concentric layer system or of exogenous trees. So, again, nakadepende yung appearance sa growth ring in a sense that the angle the growth rings makes with the face of the board, ipoproduce ng three categories of board cuts. So, flat zone, deep zone, and quarter zone as illustrated. So take note po that these cut types affect the appearance, the surface appearance of the board, but do not largely affect the structural integrity of the board. So after po ma-cut and trim ng mga piraso ng lumber, dadalhin yun sa area to be dried or seasoned. So seasoning, green wood, it refers to freshly cut wood that has not any drying treatment. In living trees contains from 30% to 200% moisture by the oven dry weight. Oven dry weight po is yung weight ng wood substance after all the moisture evaporated from wood sa oven. So kasi po, for structural wood, ang recommended moisture content kasi varies from 7% sa mga dry southwestern states to 14% naman po sa damp coastal regions. Kaso, matatapos po kasi ang pag sa process sa mill, framing lumber typically has an average moisture content of 15%. So, seasoning, it removes the excess moisture from wood. Wood is seasoned by air and kiln drying. So, mas madidiscuss po ito ng ibang reporter, yung seasoning. Kundi po ako nagkakamali sa wood preservation na part. Pero yun, seasoning is the controlled reduction of moisture. Air drying is inexpensive but slow. The green lumber is stuck in covered piles to dry. So, these piles of lumber po are made of successive layers of boards na separated by 25 millimeter or 1 inch strips. So that yung air po can flow between the layers. Or basically, naka-stuck sa covered area with spacers sa pagitan ng bawat piraso to allow air to circulate. So, the time required for drying varies with the climates and temperature of the area. Air drying is complete when moisture content of the wood is in equilibrium with the air humidity. Kaso po, yung favorable naman na moisture ay pwedeng hindi ma-achieve gamit lang ang air drying. So, pwedeng i-kiln dried after air drying ang lumber. Kiln is a large oven where all variables can be closely monitored. Drying temperatures in a kiln range from 20 degrees Celsius to 50 degrees Celsius or 70 degrees Fahrenheit to 120 degrees Fahrenheit, typically requiring 4 to 10 days. Mahalagang malaman na care must be taken to slowly reduce the moisture content of the wood. So, drying too rapidly can result in an increased cracking and warping. Dried lumber will take on moisture again if exposed to water. Ibig sabihin po, kailangan talaga mag-ingat, lalo na kapag nag-i-store at nagta-transport ng wood. So, structural lumber is not typically air-dried prior to kiln drying. So, itong picture, ayan. Itong figure po na yan is maiintindihan gamit din yung relation between shrinkage and moisture content na diniscuss ni Ms. Navalsa. So, yung table under fiber saturation point. So, since po kasi yung wood shrinks at different rates in the different direction, the combined effects of radial and tangential shrinkage can distort the shape of the wood pieces yung nasa picture po. So, yung figure shows types of distortion na pwedeng mangyari sa flat, square, and round pieces after seasoning since ang tangential shrinkage is about twice as great as radial. So next is surfacing or planing of the wood surface to produce a smooth face. Can be done before or after drying. After seasoning ko po siya ni-note itong surfacing kasi post-drying is superior because when surfacing is done before seasoning, the dimensions are slightly um, increased to compensate or shrinkage during seasoning, yung napakita po sa picture. Since ina-address ng surfacing ang minor imperfections na nag-a-arise during drying process. Kaya mas preferable talaga ang post-drying surfacing. Again, kasi nga yung dimension ay naaapektuhan in a sense na mas lumalaki tuwing inuuna ang surfacing bago ang seasoning. At nagiging sanhi ng shrinkage yon during seasoning na. So, next. Final step in a lumber production involves grading the lumber according sa quality. Typically, lumber is graded according to the characteristics that affect strength, durability, or workability. The most common grade-reducing qualities of lumber are knots, checks, pitch pockets, shakes, and stains. Due to the high degree of natural variability with lumber, it is nearly impossible to develop an exact uniform set of grading standards. Dahil doon, nagkaroon po ng mga grading techniques at standards sa iba't ibang organizations. So, ang pag-grade po kasi ng wood, by its nature, ang wood po kasi is not uniform consistently and therefore will contain defects that impacts the appearance of the lumber that is created from the wood material and syempre, pati na rin ang structural characteristics ng lumber. Kaya po yung grades is ginagamit para ma-define both quality ng product at ma-provide yung estimated cost and waste associated sa syempre sa given grade ng product as raw material. So, these grading systems for both softwood and hardwood lumber. First, hardwood grade. So, hardwood can be graded for either appearance or structural applications. The inspection is performed on the poorest side of the material and the grade is based on the number and size of clear cuttings that can be produced from a given piece of lumber. So based on cutting quantity, the wood is given classification of ito po yung mga sa hardwood grades, yung mga tawag sa kanila. Yung first, second, select, and common. Common number 1, common number 2, common number 3A, and common number 3B. For civil engineering application, appearance grades are less important than structural grades. Other grading system exist and may use some of same terminologies. Diba, sinabi ko na rin kanina na wala talagang sinusunod na standard and grading techniques, bali magkakaiba sa iba't ibang organization. So, other grading system exist and may use some of the same terminologies. Pwede magkapareho or pwede magkaiba. So, may be used to describe structural grade or an appearance grade in different products. Next, softwood grades. For structural applications is graded by visual inspection and is machine stress graded. So, ano po yun? So, under machine stress grading, each piece of wood is subjected to X-ray to measure density, which is correlated to strength and stiffness. Alternatively, the wood piece is subjected to a bending stress and is graded based on the mechanical response. So, the grade designation identifies the minimum extreme fiber bending stress, tensile stress, parallel to grain, compressive and modulus elasticity of the wood. Next. Yan. For visual classification, the basic mechanical properties of the wood are determined by testing small clear wood specimens. So, visual grade designation includes, ito naman po yung mga tawag sa softwood grades, yard, structural or factory, and shop with subgrades of select po. Select B, select C, and number 1, number 2, and number 3 commons. Yan. Number 1 commons, number 2 commons, number 3 commons. Appearance and stance. Other commonly used ratings are construction, standard, or utility and combination such as number 2 and better. And standard and better. Not all grades are used for all species of wood. And yun lang po sa wood production. Kasi naman po sa next reporter.
Good morning, my name is Jaisal Anyunisi Renario, and the next topic I'll be discussing is defects in lumber. a fault in the wood that affect its appearance and utility. But first, let me define defects and lumber. A defect is generally defined as a shortcoming, fault or imperfection, as well as an irregularity or a lack of something required for completeness or imperfection. And today, I'm going to discuss these various types of defects in lumber. Lumber refers to all harvested wood, whether in the form of logs, heavy timbers, or member used in light frame construction. Yung lumber is a strong type of wood that is processed into beams and columns for structural purposes only. The term lumber refers to felled trees. It's much rougher than timber. Yung timber at lumber, parehas lang silang type of wood. At ang pagkakaiba nilang dalawa ay depende kung nasaang bansa ka. Kunyari, sa UK, processed wooden products are commonly referred to as timber. Typically, lumber naman will still have its bark. Yung bark ay outermost covering of a tree trunk and branches like a protective skin. The primary distinction between timber and lumber is that lumber is less processed than timber. At yung defects in lumber na i-discuss ko naman ngayon halos makikita din sa defects in timber. Nuts, shakes, grain, substrate, reaction wood, pitch pockets, bark pockets, checks, splits, warp, raised, loosened or fuzzy grain, chip or torn grain, and machine burn are some of the defects that can be found in lumber. The different types of defects result from a variety of causes like natural and acquired defects caused by a broken limb or other injury, insect and fungal attack, or rapid tree growth, at yung ibang defects naman ay present na at the time the wood is formed, habang yung iba naman na-develop or worsen as the wood ages. And unfortunately, there are very few perfect pieces of lumber available. Kasi yung lumber, subjected talaga siya na magkaroon ng defects from the time it arises as a seedling to the end stage of seasoning. Una na nga ay knot. A knot is a naturally occurring defects in wood. Isa siyang circular flaws caused by a broken off branches of a tree. Madali lang siyang ma-distinguish kasi kapansin-pansin yung darker appearance and harder character niya. And knot is primarily a discontinuity and a place of weakness. Knots are unavoidable because they occur naturally during the tree's growth process. Yung imperfection na to ay dahilan kung bakit yung wood is a beautiful material to work with. At hindi lang yan dahil nakakapag-contribute din siya sa structural strength defects in construction lumber. Some types of knots are rounded, knot cluster, elongated, face knot, edge knot, pin knots, live and dead knots. The next defects is shakes. Shakes are more serious and common defects. It is a lengthwise crack or separation of the wood between the growth rings, which occurs along the face of the board and sometimes below its surface. Heart shakes, star shakes, and cup shakes naman yung most common types of shakes. Although this is naturally occurring defect caused by a strong winds, shakes can also occur during the felling or cutting down of trees into logs, as well as due to shrinkage in the log before conversion of wood. Next defect naman ay wane, kapag may missing wood or untrimmed edge sa side or corner of a board. Yun yung tinatawag na wane. This defect will only be found in a lower grade lumber. In some application, you may be able to conceal this type of defect by flipping the board over. Edging can help to reduce or eliminate wane on lumber. At maraming customer prefer yung large timbers with some wane according to some wood companies. Dahil yung wane, like the other defects, can add character to a reclaimed or other unique wood product. Next defect is sap streak. Sap streak is a heavy accumulation of sap in the fibers of the wood, which produce a distinctive streak in color. Sap streaks are discoloration that penetrate the wood fibers and are also known as wood stains. The next defect is reaction wood. Reaction wood naman is a type of woody tissue that grows in a crook stems or limbs. In the growing trees, strong winds ang nagiging dahilan kaya nakakalog yung mga puno. Dahil dito yung wood industries ay nagiging mas matibay sa area kung saan naganap yung bending action. These reaction wood areas are further subdivided into tension wood and compression wood. Depende kung saan side of a bending tree na develop yung reaction wood. Kaya may mga area na normal wood lang at may mga area naman na may exceptionally strong wood. At the same time, may part din ng reaction wood na nagka-crack kaya mahirap siyang ayusin para ma-convert sa ibang useful parts. Reaction wood causes the pith to be offset from the tree's neutral axis. Internal stresses are produced which can lead to warping and longitudinal cracking. Next defect is pitch pockets. Pitch pockets are well-defined openings between annual rings that contain free resins. Yung annual rings, yun yung layer of wood produced each year, habang yung resins naman ay clear yellow, sticky substance produced by some trees and used to make varnish, medicine, or plastics or a similar chemical substance produced for industrial use. Ito naman yung cavity siya sa wood caused by insect or some impact to the tree, and pitch pockets are typically found only in Douglas fir, pines, spruces, and western larches. Sila yung mga trees that are medium to tall, evergreen, needle-bearing, cone-producing, and have a conical or pyramidal shape. Bark pockets naman ay small patches of bark that have become embedded in the wood. Na-form naman to kapag yung small pieces of bark ay umusli na sa lumber. Itong area na to ay nakakonsidered as unsound. Next defect is checks. Ito naman ay crack sa wood that separates the fibers. Hindi naman siya nag-extend from one end to the other, pero it appears across the growth rings and it's usually caused by insufficient or incorrect drying processes or seasoning. Nag-a-appear siya sa surface or end of the board. Next naman ay splits. Kung makikita nyo, si checks, hindi pa siya nag-extend hanggang dulo. Pero itong si splits ay separation na siya ng wood talaga dahil sa mishandling or seasoning. At dahil sa rupture or separation of wood grain, kaya nababawasan na yung board's appearance, strength, and utility. Yung warp naman ay distortion of wood from the desired true plate. Ito naman yung na-deform na ang wood sa original plane surface. And the four major types of warps are bow, crook, cup, and twist. Warp is caused by differential shrinkage, differential drying caused by the manufacturing environment, or the release of internal tree stress. The next defects are raised, loosened, and fuzzy grain. When any water-containing stain or finish comes into contact with wood, it causes the wood fibers to swell, resulting in raised grain. Pagka yun ng water na nag-contact sa wood, yung wood parang magaspang. Parang yan sa picture. Raised grain occurs no matter how fine you sand the wood before wetting it. Hindi naman napipigilan yung pag-occur ng raised grain, lalo na kung gumagamit ng water-based product. Pero kailangan mo pa rin i-handle ng maayos para lumabas siya as smooth surface. So, sa magitan ng raising the grain and smoothing it before applying the water-based product and burying the raised grain, buwasan yung ganitong defect. And loosened grain naman refers to a small portion of wood that has been loosed but not displaced. Dito naman ay nag-loose na yung mga tips or edges. And fuzzy grain naman ay surface condition kung saan yung small group of fibers are loosened at one end in large numbers kagaya na sa picture. And fuzzy grain occurs frequently in certain kinds of hardwood lumber. Yung chip or torn grain naman refers sa wood surface scooped out or chipped away by the action of the cutting tools and planing tools. At dahil nga sa knife cutting against the grain with high rakes angle, large depth of cut, machining very dry or wet wood, or too few knife mark per inch kaya nagkakaroon ng ganitong defect, katulad ng nasa picture. At yung last defect naman ay machine burn. Itong defect naman na to ay kung makikita niyo yung nasa picture, may area na darkened dahil nga sa overheating during cutting. And this defect can usually be removed by sanding. At yun, hanggang dito na lang po yung report ko. Thank you.
So good day, my name is Louise Orleans and I'm going to discuss the physical as well as the mechanical properties of wood. So first, dito muna tayo sa important physical properties ng wood. So these are specific gravity and density, thermal properties and electrical properties. So the specific gravity and density is a commonly cited property of wood. Actually, pati sa water and sa soil, ginagamit natin yung specific gravity. So it is an indicator of mechanical properties within a clear state grain wood, and it depends on cell size, wall thickness, numbers, and types of cells. And regardless of species, the substance composing the cell walls has a specific gravity of 1.5. So the dry density of wood ranges from 160 kg per cubic meter for balsa and to more than 1,000 kg per cubic meter for some species. And the majority of wood types ay may densities daw na nag-range from 300 to 700 kg per cubic meter. So dito naman sa thermal properties, meron tayong 4. Thermal conductivity, specific heat, thermal diffusivity, and coefficient of thermal expansion. Thermal expression rather. So yan, the thermal conductivity is a measure of the rate at which heat flows through a material. So yung thermal conductivity ng wood is mas maliit compared sa mga metal and mas malaki naman sa insulating materials or insulators. And so the thermal conductivity ng wood ranges from 0.06 watts per meter Kelvin para sa mga balsa and 0.17 watts per meter Kelvin para naman sa rock elm. And yung structural wood na ginagamit natin sa construction is may thermal conductivity na 0.12 watts per meter Kelvin as compared to the 200 watts per meter Kelvin para sa aluminum and 0.04 watts per meter Kelvin para sa mga wool. So thermal conductivity, it is strongly influenced by moisture content. Kasi kapag ang wood daw is dry, ang cells ay may laman lamang na hangin, kaya yung thermal conductivity is very low. And as the moisture content increases, thermal conductivity increases. Kapag naman tumaas yung moisture content ng 0% to 40%, yung thermal conductivity is tataas din by about 30%. So because of the solid cell wall material in heavy woods, they conduct heat faster than light woods. This relationship between specific gravity and thermal conductivity for wood is linear. Also affecting the heat transfer in wood are increases in structive content and density, which increase thermal conductivity. So the second one is the specific heat, the ratio of the quantity of heat required to raise the temperature of the material 1 degree to that required to raise the temperature of an equal mass of water 1 degree. And as usual, temperature and moisture content ulit yung mostly nakaka-affect sa specific heat ng wood. Kapag naman ang wood ay may water, yung specific heat ng wood is increased because the specific heat of water is higher than that of dry wood. And the value of specific heat for the wet wood is higher than just the sum of the specific heat for the wood and water combined. So, yung increase na yun sa specific heat ng wood beyond the simple sum is because of the wood-water bonds absorbing energy. Kapag tumataas yung temperature, mas mataas yung energy absorption ng wood and yung relationship nila lang sa isa't isa is directly proportional sa specific heat. So, the third thermal property is the thermal diffusivity. It is a measure of the rate at which a material absorbs heat from its surroundings. So, sa wood, mas maliit siya compared sa mga ginagamit nating building materials. Because of low thermal diffusivity, the wood does not feel hot or cold to touch compared with other materials such as steel na may 0.05 mm per second. So, yung wood merong average na 0.006 mm per second And nakaka-apekto doon yung pagkakaroon ng small thermal conductivity, may moderate na density, and may moderate na specific heat. So the last thermal property is the coefficient of thermal expression. It is a measure of dimensional changes caused by a temperature variance. Thermal expansion coefficients for completely dry wood are positive in all directions. Yung expansion coefficients naman ay proportional to density and therefore mas mataas ng 5 to 10 times across the grain than those parallel to it. So, for both hard and soft woods, the longitudinal coefficient values range from 0.009 to 0.0014 mm per meter degree Celsius sa wood. And kapag nagkaroon ng combination ng swelling and shrinking, nagre-result siya into net shrinkage. So, halos lahat ng woods, most woods na may normal moisture levels is na-experience to or nagkakaroon ng reaction dito. So, the last physical property are the electrical properties ng wood. So, air-dry wood is a good electrical insulator. The moisture content is indirectly proportional to the resistivity, decreasing by a factor of 3 for each 1% change in moisture content. So, kapag once na ang wood ay na-reach ang fiber saturation point, it takes on the resistivity of water alone. And so after the physical properties ng wood, which are specific heat or density, electrical properties, and thermal properties, we're going to move on to the mechanical properties of wood. So here we have 4 modulus of elasticity, strength properties, load duration, and damping capacity. So in modulus of elasticity, here you can see the typical stress-strain relation of wood na linear up to a certain limit, followed by a small non-linear curve after which failure occurs. So etong stress-strain diagram na to is hindi siya ayan yung lagi. I mean, nagvary siya depending on moisture content and specific gravity. And nagkakaiba-iba between species. So since wood is anisotropic, different stress-strain relations exist for different directions. Merong directional longitudinal, radial, and tangential axis. So magkakaiba sila. So the second one is the strength properties na nagvary to a large extent depending on the orientation of grain relative to the direction of force. So kapag in full-size members, mostly ang tensile strength ang pinaka nami-measure or nagko-control sa capacity ng most piece of wood. Ayan, ito yung mga common strength properties ng woods. Modulus of rupture in bending, compressive strength, tensile strength, and shear strength. And less common properties naman is yung torsion, toughness, and fatigue strength. So here in the third, usually ang load duration ng woods is mas support nila yung higher loads sa short period of time than sustained loads or lower loads in much longer time. So yung design values of material properties contemplate fully stressing the member to the tabulate design values for a period of 10 years and or the application of 90% of the full maximum load continuously throughout the life of the structure. If the maximum stress levels are exceeded, the structure can deform prematurely. So, ayan, in this picture, ito yung adjustment factors for load duration working stress for wood design based on 10-year nominal duration. So, the last mechanical property of wood is the damping capacity. So, damping is the phenomenon in which the amplitude of vibration in a material decreases with time or over time. Moisture content and temperature largely govern the internal friction in wood, therefore affecting the damping capacity of wood. So, at normal ambient temperatures, yung increase in moisture content nagpo-produce siya ng proportional increase din sa internal friction pataas sa fiber saturation point. Kapag under normal conditions naman of temperature and moisture content, yung internal friction ng wood is 10 times that of structural metals, meaning mas mabilis ang wood na mag-dump ng vibrations kaysa sa metal structures kahit pa similar sila ng design. Ayan, so the different mechanical properties of wood are, again, strength properties, load duration, damping capacity, and the modulus of elasticity. So that briefly sums up the physical and mechanical properties of wood. And next naman is yung tests done on wood or yung mga ASTM to be reported by Eunice K. Sabalsa. Ayan. So, thank you for watching and listening.
Next topic naman na i-report is about testing to determine mechanical properties of wood. So, hinati na lang namin to sa dalawang ASTM since napakaraming ASTM na pwedeng i-include regarding sa wood. First is Astm D198 or yung flexure test of structural specimens. It is performed on members given the size similar to what is usually used in structural applications. It determines the flexure, compression, tension, torsion, and shear modulus of wood. Ganito yung itsura niya. Itong part na to, ito yung nagsisilbing point load ng testing machine. So, habang tumatagal, habang nadadagdagan yung weight nitong part na to, nagkakaroon ng changes sa part na to ng wood. So, yun yung kinocompute doon and inoobserbahan. Ang kinokollect na data rin dito is hanggang saan siya aabot bago dumating yung point kung saan papasok na yung failure ng structural wood member. So, it includes flexure o yung bending, compression ng short column, and compression ng long column, pati tension. Sa methods of loading naman sa wood beam, gaya nga na sinabi ko kanina, example ko kanina sa picture is point load yun. Yun yung center point loading. Meron din namang options na pwede siyang 2-point loading kung saan from left to right, same in distance niya. So, andun nakalagay yung pampabigat na part ng testing machine. So, meron naman din dito yung 3rd-point loading kung saan equally divided yung distance nila into 3. Next naman is Astm D198. Ito naman yung timber clear specimen test. Dito, ang pinagkaiba niya sa D198 is that ang ginagamit lang dito ay small specimen ng wood. It can be used to compare the mechanical properties of various species, establish allowable stresses, and determine the influence of density, locality of growth, height, and treatment of chemicals on the mechanical properties of wood. So, kung makikita nyo, iba yung itsura niya sa testing machine ng ginagamit sa D198. Dito, ilalagay lang dito sa part na to yung napakaliit na part ng wood. Hindi siya katulad dun sa D198 na tabla most commonly ginagamit or anything na mahaba yung specimen. So, it includes static bending, impact bending, compression parallel to the grain, and perpendicular to the grain, then tension parallel to the grain, and tension perpendicular to the grain. So, sa figure A, ito yung tension parallel to grain. Yung orientation niya is nakatayo yung wood sample. Dito naman sa tension perpendicular to grain, nakapahiga na yung wood sample. Same as sa compression. Ang pinagkaiba lang nila din is yung hatak or yung tulak ng testing machine. Next naman is yung hardness perpendicular to grain and hardness parallel to grain. Yung orientation, same lang din sa mga naunang figures. Ang kinaiba lang niya is yung existence netong bilog na to. Commonly, ito yung parang metal ball na nakapatong sa wood kapag nag-undergo sila ng hardness test. So, itong hardness test na to, dinedetermine lang niya kung hanggang saang part ng wood para lulubog yung kalahati ng metal ball na to. So, gano'n ka lakas na force or gano'n kabigat yung weight na kayang dalhin ng wood na hindi to lumulubog. So, ito naman sa bending, katulad lang din siya ng sa Astm D198, ang pinagkaiba lang din talaga is mas maliit lang yung wood sample compared dun sa naunang test. So, hanggang dito lang yung report ko. And next naman is yung testing machines na ginagamit for wood samples.
So, ako po yung next reporter. My name is Fernando Polvo Jr. And yung topic ko is about wood testing materials and equipment. So, the wood products experience several mechanical testing when used in constructions, manufacturing industries, and furniture. The strength of wood determines its acceptance for the intended application. The woods are needed to be checked for the breaking strength, tension, compression, flexure, moisture, and etc. Wood characteristics are checked so can be used in construction or furnitures. So, yun nga tinetest natin yung mga materials natin, especially yung wood kasi sa wood testing tayo, para malaman natin kung para sa natin siya pwedeng gamitin. Nakadepende yung sa quality, sa strength nung ating wood, kung pwede ba natin siya gamitin sa construction, sa furniture, o pang design lang sa ating construction. First natin na equipment is yung tensile, tensile tester. The properties of material including the complex, the orientation, and arrangement of fibers make wood a complex material. Various testing methods are developed to check the quality of timber. However, testing tension is also important for engineering materials. The tensile tester is available to measure these properties. So yun nga, para pag nag-check tayo ng ah, tensile strength ng ating wood, ginagamit natin tong tensile tester. Next is yung muffle furnace. So ito lagi natin nakikita sa iba't ibang testing, iba't ibang product testing. So ang gamit naman ng muffle furnace or muffle oven is a furnace in which the subject material is isolated from the fuel and all the products of combustion, including gases and flying ash. A tool designed to determine the ash percentage in wooden specimen and its vital information. So, napaka-critical gamitin ng ating muffle furnace. So, in any material na tinetest natin dito, i-check niya yung ash percentage, kung gaano kataas yung percent ng ash ng natin ng material, at para magamit natin at ma-check yung quality nung ating wood. Next naman na equipment natin is yung laboratory hot air oven. So, it measures the effect of elevated temperature, compression set, heat resistance, and hot deformation. So, yun nga, ano ba yung magiging epekto? Yun yung mini-measure ng ating hot air oven. Yung magiging epekto ng pagbabago o pagtaas ng temperature natin sa wood o magiging epekto sa quality para magamit natin sa construction. The effect of high temperatures on wooden products must be measured at the time of manufacturing. Ito yung itsura ng laboratory hot air oven. Next naman is yung color matching cabinet. So, ginagamit siya sa the quality of color is evaluated when the color remains consistent and appears same under different lighting conditions. The color matching cabinet is used for testing the color consistency issues. So, ginagamit nga natin yung color matching cabinet natin. Binabago-bago niya yung consistency ng light. At kung magbabago man yung kulay, nakadepende siya sa kung pwede natin siya gamitin sa design, sa furniture kasi magbabago yung itsura syempre nung ating product. Next is yung torsion testing machine. This is applied to the test sample by anchoring one end so that it cannot move or rotate and applying a moment to the other end so that the sample is rotated about its axis. This also measures the torsional strength, stiffness, and stress strain properties of various materials and specimen. Yun nga yung nakukuha natin sa torsion testing machine, yung torsional strength, stiffness, tsaka yung stress strain properties ng ating wood sample. So, para matest natin siya, yung parang tinitigil o ina-anchor yung isang dulo ng wood specimen natin, tapos iikot siya sa kabila para makuha natin yung lalagyan ng moment tapos makuha yung torsional strength, stiffness, tsaka stress strain. Ito naman mga kasunod is yung mga fixture lang na ginagamit sa ating mga testing equipments. Yung una is yung wood tensile fixture perpendicular to grain. It describes the size and shape of the grips used for tension testing wood specimen perpendicular to the grain. In the test, a timber specimen is cut into shape and placed into the fixture. A tensile test is conducted and the resulting tensile strength and maximum load are analyzed. So, yun nga, parang lang siya, holder, para ma-check natin yung tensile test gamit ng tensile testing machine. Next is yung tensile wedge grips wood fiber particle board. So, ginagamit din to para pang-grip lang din ng wood specimen natin. Used for determining the tensile strength properties of wood-based fiber and particle panel materials. The grips are self-aligning and self-tightening as required in Astm D198 for tension test parallel to the material surface. So yun nga, pang-grip lang din siya sa natin ng wood specimen para ma-check natin yung tensile strength tsaka yung particle ng particle panel materials natin. Next is yung point flexural bending fixture. It performs static flexure bend and cyclic flexure test. Measures flexural modulus, flexural strength, and flexural yield strength. So dito nga sa point flexural bending fixture natin, may kadalasan siya is 3 or 4 point, tapos ang pinagkaiba lang nila, magkakaiba sila ng capacity na kaya nila na load. At yun lang yung last na equipment na meron tayo. So thank you and may next reporter pa.
So I am Francis Joseph T. Bernacer and I'm going to discuss wood preservation. So in this part, malalaman natin kung ano ba yung wood preservation and bakit natin siya kailangang gawin bago gamitin yung kahoy. How does wood decay? Since wood is an organic material, it may deteriorate and decay with the passage of time. Lahat naman kasi talaga is nasisira or nabubulok pag nagtagal. Plastic or bakal, kahit na kahoy. Kaso kasi kapag kahoy, sobrang bilis niyang mabulok or masira, lalo na pag malambot lang yung kahoy or pag hollow. The principal destroyers of wood are decay caused by fungus. Ito yung mga white rot, brown rot, dry rot, and soft rot fungi. And attacked by a number of animal organisms such as termites or yung anay, beetles, carpenter ants, and limnoria. Yung limnoria naman is para lang siyang kuto na nasa kahoy. The deterioration becomes rapid in the presence of certain conditions. Isa dito yung moist condition kasi kapag moist yung environment, nag-aalaw yun ng growth of small insects or plants sa kahoy. Wood preservation. Preservation of timber or wood means protecting it from fungi and insects so that its life is increased. Yung preservative, nakakatulong siya sa kahoy para mabagal yung process ng pagkabulok nito. Since di naman talaga may iwasan yan. Increasing life makes timber more durable and it can be used for longer periods. Preservation of timber against these decaying agencies require careful selection of the environment. So, kailangan natin i-store yung kahoy sa dry or sa hindi mababasa or mauulanan. Tapos, dapat hindi rin direktang nakatapat sa araw yung kahoy pag nakastore na. Since yung environment at weather condition nakaka-apekto rin siya, nakaka-apekto siya sa kahoy. Timber is to be seasoned well before application of preservatives. Ito naman, para mas lalong mapatibay or ma-amplify yung pag-a-apply ng preservative, dapat na-season din yung wood bago malagyan ng preservatives. So, ano nga ba yung seasoning? Seasoning of timber is the controlled reduction of moisture from the wood. Ito na yung mga saps or yung dagta at tubig na kino-contain ng kahoy. This is necessary for reducing the unnecessary weight of timber, for effecting an increase in its strength, to improve its workability, to reduce the possibility of developmental of shrinkage defects, and to ensure durability of long life of timber. So, methods of seasoning. Ito yung natural, artificial, chemical, electrical, and boiling method. So, there are two general methods of seasoning of timber. Ito yung air seasoning or yung natural, tsaka yung kiln seasoning or artificial. Sa natural seasoning or air seasoning, wood in properly cut parts is stuck in a proper manner in open air for losing moisture by process of evaporation. Since natural siya, parang ibinibilad lang talaga yung kahoy sa araw, pero hindi pa rin directly. Nakastack lang siya ng maayos, then pinapapatungan ng parang bubong para nga hindi direktang sikatan or mauulanan. The stacks are so constructed to allow the free circulation of air around each part as far as possible. Ang disadvantage lang nito is masyadong matagal yung process. Inaabot siya ng 6 months to 4 years. Pero para mabilis yun, sometimes logs are placed in running water before subjecting to air seasoning. Ito na may tinatawag na water seasoning. Nilalagay yung kahoy sa running water para mapalitan yung saps o yung dagta para mapabilis yung process ng air seasoning. Dahil nga mas mabilis matuyo yung kahoy na puno ng tubig kaysa sa kahoy na puno ng dagta. So, next naman is artificial seasoning or yung kiln seasoning. Timber is dried for specific periods and under very controlled conditions of temperature and humidity in special designed kilns. Tunnel type kilns can also be used for this purpose. So, ito, halos tulad lang din siya ng natural seasoning. Kaso, imbis na sa open space lang siya ibilad, inilalagay siya sa loob ng kiln. Yung kiln is yung parang oven lang siya na controlled yung condition ng temperature. So, other methods of seasonings are chemical seasoning or salt seasoning. In this method, the timber piece to be seasoned is treated with a chemical solution like sodium chloride, sodium nitrate, or urea. The essential quality of such solution is that it reduces the vapor pressure in the surface of application. Once such a treated timber is exposed to natural drying, it is the water or sap from the inner cells that moves to the outer cells at lower vapor pressure. Dito naman natural seasoning lang din yung process niya, kaso bago ibilad, ititreat muna siya ng mga chemicals like sodium chloride, sodium nitrates, or urea. Hence, the salt seasoning sa tawag nga sa kanya. Dahil sa mga chemical na nilagay sa kahoy, yung mga tubig at dagta na nasa inner part ng kahoy is pumupunta sa exterior, tapos palabas kaya. Sa ganitong method, unang natutuyo yung loob kahit basa-basa pa rin yung labas ng kahoy. Next naman is electrical seasoning. Since dry wood is a non-conductor of electricity, but when a high alternating current is passed through a piece of green timber, heat generated is enough to dry out the moisture of the cells which do conduct some electricity. Dito naman sa ganitong method, mabilis matutuyo yung kahoy. Kaso masyadong mahal yung mga equipment na gagamitin sa ganitong method. Tapos malakas ding kumonsumo ng kuryente, kaya hindi siya economical na gamitin. Tapos dagdag pa, humihina rin yung kahoy sa ganitong method. Next naman is seasoning by boiling. This is also a quick method of removing sap from within the cells. The timber to be seasoned is immersed in water and the water is raised to boiling temperature. It is kept boiling for 4 to 5 hours. Habang pinapakulo, nawawash out na yung mga dagta o yung sap sa loob ng kahoy. On placing the air, such boiled timber dries quickly kasi nga natanggal na yung dagta sa loob ng kahoy. But at the cost of the strength and elasticity of the fibers. Kaya di rin masyado nagamit yung ganitong method. Next naman is types of preservatives. Ito yung petroleum-based solutions or yung oil-based, waterborne preservatives, and preservative paste. So first, petroleum-based solutions. These preservatives are very effective, but some are environmentally sensitive since oil nga siya. They are commonly used where a high degree of environmental exposure exists and human contact is not a concern. Ilang halimbawa nito is yung mga creosote and pwede itong apply sa mga utility poles, railroad ties, and retaining walls. Next naman is waterborne preservatives, a water-soluble chemical used to treat wood for protection against decay and insects. Advantage of waterborne preservatives over the oil-based are its cleanliness and its ability to be painted. Pero kahit mas malinis siya sa oil-based preservatives, mapanganib pa rin siya sa environment, kaya kailangan apply ng maayos sa controlled environment. Disadvantage naman ng ganitong treatment is their removal by leaching when exposed to moist conditions over long period of time. Yung leaching naman is yung unti-unting natatanggal yung chemical kapag na-expose sa moist conditions. Next naman is preservative paste, formulated by mixing the oil-borne and water-borne types. Yung preservative paste naman pinaghalo lang siyang water-borne tsaka oil-based preservative. The life of preservative treated timber products depend on the penetration, retention, and degree of fixation of preservative use. The penetration and retention of a preservative, however, depends on the preservation method. So, some of the widely used preservatives are tar, ito yung liquefied na uling, paint, pinakasikat siguro ang paint na ito is yung Lignin paint nga. Then chemical salt, chemical siya na dinisolve sa tubig. Creosote, nasabi kanina, prepared by distillation lang ng tar. Yung ASCO or sa ibang sources, ASCO, dinevelop siya ng Forest Research Institute and available naman siya sa powder form. Tapos ihahalo na lang siya sa tubig kapag gagamitin na. Application techniques. This includes brushing, charring, dipping and steeping, hot and cold open tank, injecting under pressure, and spraying. So sa brushing are the simplest method of applying preservatives. For better results, the applied preservative should be in hot condition para mas madaling kumapit yung kahoy and mas maganda yung texture niya. Multiple coats should be applied and certain time interval should be maintained between successive coats. And dapat din, may interval yung paglalagay ng coating ay yung pagpapatong ng preservative. Next naman is yung charring. Charring is nothing but burning of timber surface, which is quite an old method of preservation of timber. Yung sunog na surface is nag-a-act siya as coating ng kahoy. Kaya yung ganito method is suitable for exterior woodworks such as wood fencing poles, telephone pole, and such. In this method, the timber surface is wetted for 30 minutes para naman may resistance yung kahoy kahit papano, and burnt up to a depth of 15 millimeters from the top surface. Next is dipping and steeping. Dipping consists of immersing wood itong preservative solution for several seconds to several minutes. It allows better penetration into checks and cracks of wood, but is unsatisfactory for use as subject to abrasion. Sa ganitong method, konti lang yung protection niya against termites, tapos hindi rin siya advisable pag yung wood gagamitin na may contact sa lupa. And yung cold soaking naman, or yung steeping, well-seasoned wood for 2 to 7 days in a vat containing a low viscosity oil-borne preservative is simple and relatively inexpensive. It is thought to give more protection than dipping. Yung penetration and retention ay nakadepende sa type ng kahoy. So, para mas madali, yung dipping is parang isasaw lang talaga siya sa solution, and yung steeping or soaking naman is ibababad yung mismong kahoy sa solution. Then next, hot and cold open tank treatment. Consists of immersing wood alternately in separate tanks containing heated and cold preservatives, either oil or waterborne. So, habang nasa mainit yung na solution yung kahoy, nag-expand yung hangin sa loob, tapos lumalabas din yung hangin na yun. Yung ibang hangin. Tapos ito rin yung nakakapag-penetrate ng preservative sa kahoy. Kapag naman nailipat na sa malamig na solution yung kahoy, magko-contract naman yung wood, habang yung pumasok na preservative is mas lalo pa siya magpe-penetrate sa loob. This solution is heated for a few hours at 85 to 95 degrees Celsius. Then the solution is allowed to cool and timber gets submerged with this gradual cooling. Next naman is spraying. Spraying is an effective technique than brushing. In this case, preservative solution is sprayed onto the surface using spray gun. It is time-saving and quite effective. Mas mabilis siyang i-apply kaysa sa brush. So, injecting under pressure. The wood is placed into an airtight steel cylinder and immersed in a preservative. Increasing pressure drives a chemical into the wood. So, ito yung pinaka-effective sa lahat ng method ng pagpe-preserve ng kahoy. So, kahit mahal yung equipment na ginagamit dito, nababawi naman sa quality ng preservation. Tapos, may dalawa rin itong process, yung full cell process saka empty cell process. Sa full cell process, nagpo-provide siya ng maximum retention. Sa empty cell process naman, dito naman makukuha natin yung deep penetration ng preservative. So next, baka nagtataka kayo kung bakit walang varnishing sa types or even sa methods ng wood preservation, dahil iba siya kaysa sa preservatives, although pareho naman silang nagpapatibay ng kahoy. Varnishing versus wood preservatives. Varnishing is a liquid coating material containing a resin that dries to a hard transparent film. Most varnishes are a blend of resin, drying oil, dryer, and a volatile solvent. While on the other hand, preservatives penetrates the wood. And although not normally forming a hard protective coating, it nourishes the wood, and often maintenance is a lot easier and cost-effective than with varnish. Yung varnish ay liquid coating lang siya na tumitigas pag in-apply, habang yung preservative naman is nag-nourish ng kahoy. In a sense, top coat yung varnish and pwedeng bottom coat naman yung preservative. And yes, pwede pagsamahin yung varnishing and yung wood preservatives, pero kung mag-a-apply ka rin kung i-apply both, mas maganda kung hindi wax-based or oil-based yung preservative para mas madaling ilagay yung varnish. And yun lang yung nilalaman ng wood preservation.